the Moon, Venus, Mars, and Titan. These are the 4 celestial bodies that human probes have landed on so far. Among these 4, one is very special: Saturn's moon, Titan. Besides Earth, it is the only body in the solar system with a stable, thick atmosphere and liquid on its surface. Its surface is also very similar to Earth's. For example, it has dunes, rivers, lakes, and oceans. Furthermore, it is one of only 2 moons in the solar system known to have wind and rain, the other being Neptune's moon, Triton. Therefore, Titan has long been regarded as the most Earth-like celestial body in the solar system. Most importantly, it might harbor forms of life unknown to us, and humans have already explored it. So in this video, I can bring you many real photos and data from Titan. Titan was discovered in 1655 by the Dutch astronomer Christian Huygens. His discovery was largely influenced by Galileo. In 1610, Galileo discovered Jupiter's 4 largest moons, and Huygens had always been fascinated by this. So, in 1650, he and his brother began making telescopes, and it was with one of these that they discovered Titan. This was also the first of Saturn's moons to be discovered by humans. In 1847, John Herschel, the son of William Herschel, officially named the moon Titan. The Titans are a race of deities in Greek mythology who preceded the Olympians, symbolizing power and mystery. This name is still used today. As of March 11, 2025, Saturn has 274 confirmed moons, making it the first planet in the solar system to have over 200 moons. I remember when I made a video about Saturn over a year ago. It had 146 moons, and even then it had the most moons in the solar system. In just over a year, more than 100 new moons have been discovered, far surpassing the number of moons of any other planet. Titan is the largest of its more than 200 moons. Its diameter is about 5,149 kilometers, making it 50% larger than the Moon and even larger than the planet Mercury. However, its mass is only 40% of Mercury's because while Mercury is mainly composed of iron and rock, Titan is mostly ice, giving it a lower density. In 1979, Pioneer 11 captured the first image of Titan, but the photo didn't reveal much detail. It wasn't until a year later, when Voyager 1 and 2 visited Titan, that its unique characteristics were discovered. First, Titan's atmosphere is extremely thick, with multiple layers. It is the only moon in the solar system with an atmospheric density greater than Earth's. Let's compare it with Earth's atmosphere. Titan's atmosphere extends much higher than Earth's, reaching over 600 kilometers from the surface. In contrast, Earth's atmosphere is mainly concentrated within 100 kilometers. From the surface up to about 40 kilometers is its troposphere, which is its weather activity zone. The main components of this layer are nitrogen, methane, and hydrogen, with nitrogen making up about 95%. This is similar to Earth, as our atmosphere's main component is also nitrogen. However, Titan's atmosphere has no oxygen, but contains a large amount of methane. Titan's methane cycle is like Earth's water cycle. It also involves evaporation, condensation, and precipitation. This methane rain falls to the surface, forming lakes and rivers. From 40 kilometers up to 300 kilometers is the stratosphere, its photochemical reaction zone. In this layer, the nitrogen concentration rises to nearly 99%, while the methane concentration drops to about 1%, and hydrogen is less than 0.1%. Under the sun's ultraviolet radiation, photochemical reactions occur, causing methane to break down and form more complex hydrocarbons like ethane, acetylene, and hydrogen cyanide. These organic molecules form a haze layer, which is why Titan appears orange and its surface is obscured. From 300 kilometers up to 600 kilometers is the mesosphere, its smog layer. This layer has a large amount of condensed organic molecules forming small particles, similar to smog on Earth. These particles eventually fall to the surface, providing it with organic materials, somewhat akin to the chemical reactions before life began. Then, from 600 kilometers upward is the thermosphere, its high-energy particle collision zone. This is because this layer primarily collides with the solar wind and Saturn's magnetic field. This is also the thinnest layer of Titan's atmosphere. Although its atmosphere is much thicker than Earth's, its surface atmospheric pressure is only about 50% higher than Earth's, at around 1.5 Earth atmospheres. If we were to stand on Titan's surface, we wouldn't need a spacesuit, just an oxygen mask to survive. Of course, the extreme cold would be a major problem. Titan's surface temperature is extremely low, about -179 degrees Celsius. It receives only about 1% of the sunlight that Earth does. And before this 1% of sunlight reaches the surface, about 90% of it is absorbed by the atmosphere, leaving only 0.1% of the light that reaches Earth's surface. This temperature is actually due to the greenhouse effect produced by methane in Titan's atmosphere. Without this greenhouse effect, Titan would be even colder. As early as 1995, observations from the Hubble Space Telescope suggested that liquid methane might exist on Titan's surface. This prediction was later confirmed by the Cassini mission, which found that there is indeed liquid flowing on Titan's surface. But it's not water. It's far too cold for that. These liquids are liquid methane and ethane, which even form vast methane seas and lakes. It's quite amazing to think that the natural gas we use for cooking exists as vast seas and lakes on this world. Moreover, it evaporates and falls as rain, just like water. Scientists discovered a very large methane sea in Titan's North Polar region called Kraken Mare, which is the largest methane sea on Titan. Fortunately, there is no oxygen on Titan, otherwise, it might have exploded long ago. Titan's surface is younger than expected. Although it formed along with the other moons of the solar system 4.5 billion years ago, its surface isn't that ancient. Scientists estimate its surface age to be between 100 million and 1 billion years old. This suggests that some kind of geological activity has resurfaced it, covering the old terrain. Titan's surface is much flatter than the Moon's or Mars's, with very few impact craters. Radar data shows that Titan's terrain generally varies by no more than 150 meters, with only some mountains exceeding 1 kilometer in height. This could be because the falling methane rain has filled in craters, or because material from cryovolcano eruptions has covered the original landscape. These cryovolcanoes erupt a mixture of water and ammonia, not molten rock, making them completely different from Earth's volcanoes, more like ice volcanoes. Besides ice volcanoes, scientists have also discovered many long, linear features stretching for hundreds of kilometers, resembling sand dunes on Earth. In 1997, NASA, ESA, and the Italian Space Agency jointly launched the Cassini-Huygens probe, with the goal of exploring Saturn and its moons. This mission included the Cassini orbiter and the Huygens lander, which was designed to land on Titan. On January 14, 2005, the Huygens probe successfully landed on Titan. The entire descent took about 2.5 hours. During its descent, Huygens captured images of Titan's mountains and rivers. This image here was taken by Huygens during its descent, showing rivers on Titan's surface. You can see the main channel and many tributaries below, looking very much like rivers on Earth. This is the first picture it took upon landing. You can see many pebble-like rocks around. Scientists speculate this might be a dried-up riverbed. These rocks are not stone but frozen hydrocarbons. Huygens operated on Titan's surface for 72 minutes before its battery ran out, leaving it there forever. Although the Huygens mission has ended, it doesn't mean human exploration of Titan has stopped. There are still many mysteries about Titan to solve. For example, where does all this methane come from? And could there be methane-based life? It is hypothesized that life could exist in Titan's liquid methane lakes, just as life on Earth exists in water. Such organisms would inhale hydrogen instead of oxygen, metabolize acetylene instead of glucose, and exhale methane instead of carbon dioxide. Some might think this sounds absurd. Given Titan's harsh environment, why do these scientists still believe life could exist there? Actually, this isn't just a wild guess by scientists. It's a hypothesis based on actual observations of Titan. Two main anomalies led to this speculation. The first anomaly is the unusual flow of hydrogen. The hydrogen concentration is high in Titan's upper atmosphere, but significantly decreases near the surface. Logically, this hydrogen should be evenly distributed, but it seems to be absorbed by something. So, they speculate that if some form of methane-based life exists on Titan, it might use hydrogen as food for its metabolism, much like some microbes on Earth. There are indeed microorganisms on Earth, such as methanogens, that use hydrogen as an energy source. They don't need oxygen and can produce methane from hydrogen and carbon dioxide. They could breathe without oxygen in the extremely anoxic environment of the early Earth, and Titan's current environment is very similar to that of early Earth. The second anomaly is the unusual scarcity of acetylene. The concentration of acetylene on Titan's surface is much lower than expected. Normally, ultraviolet light breaks down methane in Titan's atmosphere to produce acetylene, so there should be a lot of it on the surface. However, observations show that the acetylene content on Titan's surface is very low. These two anomalies led scientists to speculate that if there is life on Titan, it might be using hydrogen and acetylene as an energy source, releasing methane after the reaction. This is similar to some extremophile microorganisms in Earth's deep-sea hydrothermal vent environments, which do not rely on sunlight, but use chemical substances as an energy source. Scientists believe that methane-based life on Titan could have a similar metabolic pathway. However, this is just speculation. There is no evidence yet. While these phenomena fit the hypothesis of methane-based life, no actual signs of life have been found. It could also be due to other unknown reasons. To investigate these questions, NASA plans to launch the Dragonfly mission next year, which is expected to arrive at Titan in 2034. Previous probes could only work near their landing site, but this probe has 8 rotors, allowing it to fly to different locations like a large drone. If such organisms are indeed discovered, it will completely change our understanding of life. Personally, I am willing to believe that there is methane-based life on Titan or other forms of life we don't know about. But I don't believe in the other idea, terraforming Titan, terraforming Mars, or even colonizing other planets. You must understand that all the planets outside of Earth that humans have explored so far have environments that are far more hostile than Earth's. Let's not talk about distant places, just consider Mars colonization. No matter how harsh the deserts and polar regions on Earth are, they still have groundwater. But on Mars, no signs of liquid water have been found to date. Moreover, Mars has no magnetic field and a very, very thin atmosphere. It's simply not possible for humans to live there long term, let alone Titan, a place that's over minus 170 degrees Celsius. Making it warmer is impossible with current human technology, and I believe it won't be achievable for at least the next few hundred years. That's because almost all celestial bodies in the solar system get their surface heat from the sun. The distance from the sun directly determines the surface temperature, except for Jupiter, which radiates heat outwards, though the reason for that is currently unknown. Perhaps microorganisms can survive in such environments, but humans cannot. The human species is too delicate. So, when you hear news about humanity migrating to other planets, just take it with a grain of salt. Don't take it too seriously. Instead of thinking about abandoning Earth and moving to other planets, we should think about how to protect Earth and solve our environmental problems. Protecting Earth's environment is certainly much easier than terraforming other celestial bodies. Never think that if we mess up Earth, we can just move to another planet. At humanity's current technological level, if Earth is truly ruined, it's basically a dead end for us. And even a ruined Earth would likely have a much better environment than any other planet.